for you. All right. Continue. You guys with that? Now this one, obviously, if I rotate this, and again, you don't have to do this step. Let me see if I can do this semi-decent. Oh, Jeff, remember that one. Yeah, no, that's not so. It's not too bad for me. That's the shape it would create if you rotated it. For me, that's remarkable and good. So it makes this little weird-ass, maybe it's a bird map or something. And we just figured out the volume of water or something it could hold. You guys see that? Now, the first thing I can do to a problem like this, notice I keep rotating around the x-axis, the y-axis. Look at the second one. It's exact same, except I'm rotating it around y equals -2. Well, shit, Jeff. The region is the exact same region, but now I'm rotating around. Where's y equals -2? What kind of thing is that? Parallel to the x-axis. So I know I'm still going to use integral dx. But here's why I made a big deal out of you got to figure out what your radii are now. Now here's what's neat. If I rotate that region, can you see how this middle region is going to be empty? Okay, I like it. I like it. So there actually is a bowl somebody gave me. It's a bowl, and it's got a hole at the bottom, and I'm like, okay. I'm not sure what the hell you're supposed to do with this bowl. Sorry. On your own, that's interesting for you. But this would be, if I rotate this sucker, it'll be held together, but it's going to circle in this hole in the middle. So maybe it's sort of like a bundt cake pan. I don't know. You guys with me? Have you ever seen a bundt cake pan? It's got the thing in the middle. You plop it out. Okay. You can Google bundt cake pan, B-U-N-D-T, later. So what this is anytime I make the axis not hug the region. So what I'm about to do isn't just because I made it not the x-axis, but it's because does my region hug the axis I'm rotating around? No. The axis I'm rotating around now is this axis. There's an inner radius. What is this inner radius? What is it? 2. And what's radius is always the distance from the axis of rotation to whatever you're going to. So this inner radius goes up to the region. That is 2. Radius can't be negative. What's the outer radius? The outer radius would be from the axis to the edge of the region I'm working with. What's that outer radius? X squared. This is going to x squared here, right? That's what that is. That's x squared. Plus 2. So everything you have to do can be done in 2D. You don't have to suddenly be able to sketch 3D. If you can, do it. That's awesome. I want to see some of that shit so I can be jealous. Why is that x squared plus 2? Because how far away from this is it? It's 2 plus x squared. It's that simple. So identifying what the radiuses are, that's one thing. Now, we haven't done a problem like this yet, but if I just did this, integral 0 to 2 pi x squared plus 2 squared dx. That would be assuming that it's solid all the way through. Now I'm assuming that it actually hugs this axis, that it's solid all the way through. But what I have to subtract off, I have to subtract off the inner shit. I need to make the inside empty. So really the way to set this up is outer radius squared minus inner radius squared. I got to subtract that middle stuff out. That's the cookie cutter step I was talking about earlier. So if you take a real quick peek on the other side, this is a washer. That's what it looks like. Pi outer radius squared minus inner radius squared. So you get that empty middle piece. And now that you've got the integral set up, it's a beautiful polynomial, easy to do. Go ahead and finish that out. So what's interesting is, do you see how that is that bigger or smaller than the volume from the first one? It's obviously bigger by this much. And students sometimes are confused because it's like you hollow out the middle. I really want this to make sense. If I rotate this pen around my finger, I'll make a certain area circle, right? If I rotate this pen around, I'll make a certain area. Now if I take it and I say, no, I want to rotate it around that, now it's going to go much further out. It's going to make this bigger circle. So I've taken my region away from my radius I'm rotating around. So it's going to rotate in this bigger arc. So it's going to go through a lot more space. So sure, the middle is empty. You got the same region though, and it's further. It's going through more space. So you're going to get more volume at the end. And you can make bundt cakes. Pretty yummy. This is cake. So when do you have to do this inner radius thing? Anytime your region is not hugging the axis you're rotating around. Talk really slow there, which normally means it's a good note to take. So here, you guys try this one. Down this lower corner here. By the way, this is the banana problem I promised earlier. Yeah, that's a mathematical banana. So is that cool? That's the region we're talking about? Hopefully you don't have to do a lot of work to see where they're going to meet. I'm going to rotate that around the x-axis. So do I do discs or washers? Washers. And personally, I hate that we kind of separate those. But you at least have to identify, do I need to worry about an inner radius or not? I do. Why? Because my region does not hug the axis I'm rotating around. I like it. So go ahead and try to set that up. Go ahead, try to set it up. You got an outer radius you got to figure out, an inner radius you got to figure out. Rotate around the x-axis. What's my inner radius going to be? Come on now, where did I stop? Stopped at x squared. I mean, that's all there is to it, right? That's why you don't want to skip the step of sketching it, and then you don't want to skip the step of actually putting the radius in. So what's the outer radius? You go out to the outer edge. The outer edge there is 2x. Well, I don't have to do any plus 2 or any weird shit like the last one because my radius of rotation is an axis. So it's 0. Maybe. So now this is going to be pi integral from what to what? What are we doing, dx or dy? Dx, because I'm rotating around x-axis. So what's x doing? 0 to 2. My outer radius was 2x. My inner radius was x squared. So the outer radius, that would make the big ass disk, minus the inner radius stuff squared, would be the cutting out the middle. And then go ahead and do it. See me looking at me like, what? Do it. This is kind of cool. 5 of those minus 3 of those is 2 of those, which is 64 pi 15. You multiply this by 5, right? Yeah. You multiply this by 3. So I got 5 of these minus 3 of these is 2 of these. And twice 32 pi is 64. I love you guys. Huh? What's 5 somethings minus 3 somethings? 2 somethings. And what's 2 32 pi's? 64 pi. Do you have to be able to do that to do math? No.
That's actually really useful. That actually comes into play more than you might think. Okay. All right, try to sketch this last one here.
So it's negative y squared, so it should be sideways, but it's opening. Yeah. Listen, I know they meet here. Do you see that? These two meet here. So what I did here is I added y squared over back to it. So I know they meet at y equal 2 and y equal negative 1. So I just graphed x equal negative y squared for this. But then I know that they meet here and here. And what kind of thing is this? It's a line. So then I just got to connect those. Look how little work I had to do. If I find where they meet, and I know what the shape is, I could just draw the shape in between where they meet. Or not. Either way would do it. And I'm going to, now this one's really fun. I'm going to rotate it around x equals 2. So this is my axis of rotation here. So now everything's kind of like in terms of this. See that? Show it. So what's my inner radius going to be? Yes, it's the curvy dude. It's the negative y squared. I mean, do you see what I'm saying? So if you, the less you graph and the less you use the graph, the more you're going to make mistakes. And I went from there to the curvy dude, so it's got to be the curvy dude. And what's the outer radius going to be? And then that's going to be negative y squared plus 2. And what's the outer radius going to be? Yes, negative y minus 2 plus 2. Oh, I should have done all that sideways. So that's just, of course, that's just negative 1. Let's see, that doesn't make sense. Think about this for a second. Oh, okay. That's, all right. I should not have done all this sideways. All right. You guys ready? Take all this away. That's my fault. I just turned it sideways just to show you, but we got to be a little careful here. How far apart are these? Well, what's this? 2 minus,
what's this? What is this? This is negative y minus 2. So this radius, this outer radius, is 2 minus negative y minus 2. Make sure you guys get this idea. How do I find the distance between two things and make sure it comes out positive? I do the bigger one minus the smaller one. So when I turned it, I thought it would make it easier for you guys to realize what we're doing, but it actually kind of flipped what was bigger and what was smaller. What's the biggest thing up here is the radius, is the axis of rotation, right? It's 2. It's bigger than all the other shit. So what's the outer radius? It's going to be 2 minus this dude. That's how far apart they are. So if I said how far apart are 7 and 11, what do you actually do in your head? The big minus the small. And what is the radius? It's going to be how far apart the axis is from the thing, from the wall I'm going to. So 2 minus negative y minus 2. So what's the inner radius going to be? Yes, this is going to be, inner radius is going to be 2 minus negative y squared. So 2 minus negative y minus 2 is y plus 4. Now, here's a way to check. You ready? Here's a way to check. What's the value of y right here? What's y right here? Negative 1. How far apart are these? Just look at it. 1, 2, 3. So when y is negative 1, the outer radius and the inner radius, actually, they both agree here, should be 3. So what I get? So negative 1 plus 4 is 3. 2 plus negative 1 squared is 3. See, so you can check your statements for radius by taking specific places that you can just see what it's supposed to be. Make sure it is that. That's what I was doing in my head when I turned around. Like, I'm getting negative radii. I did something. Oh, shit. Big minus small. Okay, maybe. So how do I set this integral up? Let's see. I don't know how much room you guys got left. So there's my outer radius is y plus 4. And of course it's going to be integral d y, not just because they're in y, because I'm rotating around something parallel to the y-axis. So I know it's going to be dy. So what's y doing across this region? Going from negative 4 to... Sorry, what's y doing, Jeff? Y is going from negative 1 to 2. Of course, I didn't leave myself much room. So I got pi on the outside, and then I just square the 2 radii. So the outer radius is y plus 4 squared minus the inner radius, which y and 4 are bad things for me. So there I get pi y squared plus 8y plus 16 minus 4 minus 4y squared minus y to the 4th. Is that cool? Just foiling that stuff out. So you're going to get negative 3y squared minus y to the 4th plus 8y plus 12. Just get all my terms together. I mean, this step is the easy step now. It's just a bunch of foiling, combining terms. Now you find the antiderivative, and then you throw shit in there. And you know you're wrong if the answer comes out negative. Because we're actually finding true physical volume here. Not, like if I find stuff and it could be negative, it's because it could be one direction or the other. But this is physical volume. It can't be negative. Now, real quick, so I'm done with it. You guys can do that. That should be the easy part. So on the back, I try to show you. Now, real quick, I want to. Why, when I do around the x-axis, why has it got to be dx? And here's why.
if I rotate around the x-axis, how do I find my circles? So this circle exists at what position? How would I identify that circle? It's a circle that is at the certain what position? How do I find my circles? On the x-axis. For any value of x, there's a circle associated with it, right? So I have to find it by going along the x-axis. Therefore, it's got to be integral dx. I've got to move along the axis I'm rotating around. So if I'm rotating along the y-axis, then I will use washers or discs. It has to be integral dy, because then I'm going to locate them going up and down. So I captured that idea here. Blah, 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 blah. So the next method we're going to talk about next time, as promised, here's my rectangles coming back into play. And if I rotate them, I make these cylindrical shells. Oh, shit. And I like this shape. Looks like a big thing of cheese or something, but... So part of this is going to feel very familiar. See that part there? That looks very much like early part of chapter 5. When we have so many rectangles and I find an area. But now if I rotate the rectangle, I make a shell, and if I add up all those shell volumes, I get the volume of the whole thing. And why do we have shell method? Well, if I rotate around the x-axis for washer method, I have to use dx. What if my functions can't be solved in terms of x? Then I'm shit out of luck. So what's really funny is, anything the washer method wouldn't work for, the shell method will work for. Now there will be some problems that you can do either method, and then one of them might be easier than the other one, but there's a lot of problems where only one method will work. So obviously, it'll make a little more sense once we get into how this thing works, and then I show you, well, which ones can you not do no washer method, which ones can you not do shell method. Okay, so that's in our future. Otherwise, I think that's plenty that I crammed into your brain. Please appreciate how colorful this is. For me, it's pretty good.